after we create the XY chart, we're going to choose values of X to plug in. Okay, that's the plug chart of plug and chug. Then we're going to solve for the corresponding Y values. We're going to make sure we have our XY chart filled out. Fill out the XY chart. And graph the points. And it's going to be as simple as that. Now, in order to graph a line, I technically only need 2 points. Because to have a line, I only need 2 points for it to go through. Okay? So we only need 2 points. However, because we want to make sure that we get the work correct, we're going to use 3 points. That third point that we're using really is a check. If we get 3 points to go in a line, that means that we definitely have the right line. If one of the 3 points can't seem to quite fit in the line, that means we've done something wrong. And that's going to allow us to go back and say, hey, what did I do wrong? Where are my calculations wrong? Mr. Matlock.
Don't we do this in either 5th or 6th grade when we solve for the equation?
My understanding is you did something very similar to this after CST last year. All right, the solution to a linear equation is a line. That is to say that you cannot just tell me, hey, Mr. Boots, the solution to this equation is insert number here, okay? The solution to an equation, a linear equation, is a line, meaning that there is an infinite number of points all lined up right in a line that could be answers to that solution. We're going to explore that or see that later on when we graph a solution. How do we know an equation is a linear equation? Well, first thing, its solution graphs a line. Well, that makes sense. However, sometimes you're going to run into a question on the CST on a test somewhere. It's going to say, hey, which of these is a linear equation? And if you spend all of this time trying to graph all 4 equations that are given to you, not only are you probably going to confuse yourself at some point in time or another, you're also going to waste a lot of time. So one way, you can just look at an equation and say, hey, I know that's a linear equation. The way you can do that is a linear equation will always have an x and a y and no exponents. So if you're ever faced with the question, which of these is a linear equation, all you have to do is find which one has an x and y and no exponents. Simple as that. All right? So we're going to look over here at this first problem that we're being asked to graph. This is y equals 2x squared. I know that this is going to graph a line because it is a linear equation. It has a y, it has an x, there are no exponents. I know this is going to graph a line. My expectation is it's going to graph a line. So I have my xy chart that I've created down here, and I want to pick 3 x values. Picking x values is all about choosing x values that make sense and that are easy to work with. There's one x value that you should always choose because no matter what, it is going to be probably the easiest value to work with. Michael is holding up this in front of his face, that is a 0. 0 is always a perfect choice because we know 0 is so easy to work with. Anything times 0 is?
0.
Anything plus 0 is?
0.
The same number. All right? So that's going to make zeros really easy to work with. So what you can see here is I've started to show the work right here for x is equal to 0. I've taken the equation y equals 2x. And so I'm going to plug in that 0 for x so I can figure out what y is. I'm going to try and find the corresponding value for y. Or what is y when x is 0? So now all I have to do is solve for y. Well, solving for y is really easy here. All I have to do is follow order of operations. 2 times 0 is my multiplication, gives me 0. 0 plus 3 gives me 3. So I know for my t-chart, my corresponding value for y is 3. If x is 0, then y is 3. Now I need to pick some other values. The next values are really going to determine what's going on in this x term. So inside this x term, it is 2 times x. I want numbers coming out of that term that are going to be really easy to deal with. All right? So realistically, the way I think about this is I want these numbers to be whole numbers. At this point, what can we multiply times 2 and get a whole number? William.
Okay, that's starting now.
Genesis.
Multiplying it by 1.
1 would work. What else? William. 2 would work. Oscar. 3, 4, 5, 6, 7, 8, 9 would all work. Ricardo.
1 trillion.
1 trillion would give me a whole number. However, we also have to start thinking about the grid that we're working with. We don't want to be going way off of our grid. Otherwise, we can't actually graph it. Michael. 25. Again, we want to stay on our grid. Also, negative values would work here. -1, -2. So basically, whenever we have a whole number coefficient here, any whole number or integer is going to work just fine. So I have chosen for you, you can see that the x values I'm choosing to plug in, x equals -1 and x equals 1. I like those because multiplying by 1 is so easy. So I'm going to choose the x values of -1 and 1. Now I'm going to plug those values in. X equals -1. So y equals 2 times, instead of x, I'm putting -1 plus 3. Following order of operations to solve for y. 2 times -1. -2. What's really important here is that the most mistakes that happen in the middle of your work, Mr. Ross, has to do with your ability to recognize good dates and bad dates. So Oscar has appropriately recognized this as a bad date. Now we need to add -2 plus 3. That's going to give me +1, taking the sign of the larger number. So I'm going to come down here into my chart, and it says when x is -1, y is +1. All right. Now the other x that I chose was +1, so now I'm going to plug in x for 1. Y equals 2 times 1 plus 3. Solving for y, all I got to do is follow order of operations. 2 times 1 is
2.
plus 3. 2 plus 3 is...
Oh, that's where I'm in.
So when x is 1, y is... we need to graph our points and draw our line. So I've got -1, 1. That's my first coordinate pair. That tells me to go over -1, so that's backwards 1 and up +1. Oops. Gets me my first point right here. Next point is 0, 3. That tells me to go left or right 0. Okay, that means I'm going to stay right there on the y-axis. Up 3. Last one is 1, 5. That's going to tell me to go over 1, forward 1, and up 5. From here, there is a very important piece of information that I need to share with you, and that is that we always draw our lines with a straight edge. The reason for that is because if you don't draw your line with a straight edge, sometimes when you have points that are slightly off, you tend to curve your line just ever so slightly to make it fit, and then you don't recognize that you have something wrong. So, there are many different things you can use as a straight edge. One of the easiest things you can use as a straight edge is you can take a piece of paper, you can fold it into 4 and just get a nice good crease on it, and suddenly I've got a nice good sturdy trusty straight edge for Genesis to use. Now, I'm going to use a book because the iPad is not particularly friendly with my trusty paper straight edges. And I'm going to draw a line straight through all 3 points. You'll notice on the end of my line that I'm drawing an arrow. Why am I drawing arrows on the ends of my lines?
Because it still keeps going.
Andrew. Yeah, because these lines are going to go forever, meaning our solution goes on forever. I could pick a point way out here in space. As long as the line went through that, that point would be a solution. If I plugged in the values right here on this line, that would come out equal. All of these values, all of these points, when we plug them back into the original equation, come out equal. So just as one example of that, I'm going to take our point 0, 3 and show you how that works. So in our point 0, 3, that's 3 is the y, is equal to 2 times 0 plus 3. We're proving that this point is part of the solution, Mr. Posey, because 3 is equal to 2 times 0 is 0 plus 3. 3 is equal to 3. So what it's saying is every point on this line makes this equation true. Okay? The equation that we're given here is y equals 5, and I've changed it to x just so there's no confusion, minus 5. So we want to draw our xy chart down here, and then I want to choose some x values that are going to be good for this. What is the first x value that we should absolutely choose every time? Kevin? Incorrect. Andrea? 0. She's showing me a 0. So the first y that we are always going to choose is 0. I like to choose a negative number and a positive number, one on either side. You don't necessarily have to. I'm going to look back up here. I'm going to look at this, and I'm going to focus in on this term right here, 5x. And I want to think about what numbers are going to make that a whole number. Jackie. 4. I want to actually work with smaller numbers if I can. 2 would work. 1 would definitely work. 3 would work. Negative numbers also work. I'm always going to choose, if it makes sense to me, I always try to choose 1 and negative 1. And these both make sense because both of those are going to give me an integer value to work with after that multiplication. So I'm going to be using negative 1, 0, and 1. When x is negative 1, my equation becomes y equals 5 times, instead of x, I'm putting in negative 1 minus 5. I'm going to leave change switch that just so I don't make a mistake there later on. So as I come through and simplify this, 5 times negative 1 gives me negative 5 plus negative 5. So when x is negative 1, then y is negative 10. So I'm going to go ahead and put that down in my cheat chart. When x is negative 1, y is negative 10. We just proved that. So when x is 0, that makes my equation y is equal to 5 times 0 plus, minus 5. Leave chain switch that. 5 times 0 is 0. And so when x is 0, y is equal to negative 5. Put that down here in my chart. When x is 0, y is negative 5. And the last one, we're going to use 1. Y is equal to 5 times 1 plus negative 5. 5 times 1 is 5 plus negative 5. So when x is 1, y is 0. This is where we have to be really careful, making sure that we're graphing our points correctly. Whenever we have x or y is 0, remember those are the points that we most likely are going to graph incorrectly. So we have to be very careful when we graph those. The first point we have is negative 1, negative 10. So it tells me to go over negative 1, backwards 1, and down 10. So my first point is down here. Next point is 0, negative 5. That tells me to move left or right 0. Don't go anywhere. Y of negative 5 tells me to go down 5. And finally, my last point is 1, 0. That tells me to go over 1 and up and down 0. So just stick right there. Once I've got my 3 points, I want to make sure I draw my line through it. Using my straight edge. I can see that I haven't drawn a particularly good line here. It doesn't quite go through my point, so I'm actually going to try again. Oop, lost my points too. That looks better. Okay. And making sure I put my arrows on there so we are clear that this is going to go on forever. Michael. Last thing before we move on, I want to look over at this equation and I want to talk about choosing good x values. So obviously the first x value that we want to choose is what?
1.
0. Always choosing 0. Now the second x value we want to choose, this one's going to be a little bit trickier here. I want to zoom in on this term right here, and I want to think to myself, what is going to give me whole number or integer values here? What can I multiply negative 1/2 by and get something that is a whole number or an integer? Genesis?
Multiply by negative 1.
If I multiply by negative 1, that's going to give me
Over 1.
negative 1/2 times 1 over 1, which is going to give me negative 1/2. That's going to make things more difficult to deal with. I'm going to have to start adding fractions, and I'd rather not do that. So we have to think a little bit more carefully here. Ricardo, what do you think?
2.
2 would be an excellent choice. So the 2 does what in this multiplication? It's going to cancel out with the 2 down here. So what Ricardo has decided is that anytime there's a fraction coefficient he's going to use the denominator as one of his x values. What can we use as our third x value here? Oscar. The opposite. So we could use -2 as well. So one key point that we can walk away with today is that anytime we have a fractional coefficient, we should use the denominator and the denominator's negative as x values. Okay?